Alright, 10.6, number 10. Find equations for the horizontal and vertical tangent lines to the curve. This is going to be a big old problem. So, alright, so first thing you want to do is you find out what x is. X is r cosine theta. R is right there, so x equals 1 plus cosine theta times cosine theta. So x is cosine theta plus cosine squared theta. And now you can find dx d theta by finding the derivative of that, which would be negative sine theta plus 2 cosine theta times negative sine theta. We could set that equal to 0, and I'm going to pull out a negative sine theta. Alright, so we're solving that, finding when it's equal to 0, so you can set each of these equal to 0. Negative sine theta equals 0, so theta equals 0, pi. We're going from 0 to 2 pi, so I'll include 2 pi. So these are all possibilities that we have a vertical tangent. We're finding vertical tangents whenever dx d theta is 0 and dy d theta is not 0 at that same point. So those are three possibles. We'll set this equal to 0 and solve. So cosine theta equals negative 1/2. Where is cosine negative 1/2? It's in the quadrant 2 and 3. So that's a 60 degrees, so 120, or 2 pi over 3 and 4 pi over 3. Alright, so those are vertical tangents. So I'll say possible. Alright, so right now we've got theta equal to 0, pi, 2 pi, 2 pi over 3, and 4 pi over 3. Those are your possible vertical tangents. So now we do it over again, and we're going to look for horizontal tangents. So y is equal to r sine theta. So y is equal to 1 plus cosine theta times sine theta. So sine theta plus sine theta cosine theta. So dy d theta equals cosine theta plus, we'll have to do a product rule here, so sine theta times negative sine theta, so that's negative sine squared theta plus cosine theta times the derivative of that, so times cosine, so times, or cosine squared theta right there. Okay, so we're going to set that equal to 0, and we're going to solve it. It's a theta, it looks like a t. I've got two cosines. I'm going to rewrite negative sine squared as in terms of cosine. We know using our Pythagorean identity, sine squared of anything, I'll say x plus cosine squared, x equals sine squared here, or negative sine squared. Move that over, so it's going to be cosine squared x minus 1 equals negative sine squared x. So I'm going to replace my negative sine squared with cosine squared theta minus 1 plus cosine squared theta. That's that one. So I have two cosine squared thetas plus a cosine theta minus 1. And it looks like a quadratic type, a factorable trinomial. That's a quadratic type. So if you think of it as 2a squared plus a minus 1, that factors into so 2a, oops, that's an a. So 2a squared plus 2a minus 1. So that factors into that. So in terms of cosine, or in terms of theta, we have 2 cosine theta minus 1 times cosine theta plus 1. Set each of those equal to 0. So cosine theta equals 1/2. And cosine theta equals -1. Cosine is 1/2 in quadrant 1 and 4. So 1, 2, square root of 3. So that's 60 degrees, or pi over 3, and 5 pi over 3. And cosine's -1 at pi. Alright, so now possible horizontal tangents. We've got theta equals pi over 3, 5 pi over 3, and pi. And if there is no overlap here, we'd have our angles, but it looks like, let's see, pi occurs in both of them. So we don't know if it's a vertical tangent there or a horizontal tangent. So what we need to do is probably grab another sheet of paper, and we're going to explore, we're going to find the limit of dy dx as theta goes to pi, and dy dx is equal to dy d theta over dx d theta. Okay, so dy d theta we found up there. That was, I guess one version would be 2 cosine squared theta plus cosine theta minus 1. Dx d theta, negative sine theta minus 2 sine theta cosine theta. So now, if I plugged in pi into the top and into the bottom, we know we're going to get 0 over 0, which is indeterminate form. So we don't know what happens as theta approaches pi, because it's indeterminate. So we'll use L'Hopital. So we'll find the derivative of the top, the derivative of the bottom, and send theta to pi and see if we get our result. If we end up doing that and we get 0, that means that we have a horizontal tangent at that point, at theta equals pi. If we end up getting infinity or negative infinity, that means we have a vertical. So we're going to apply L'Hopital's. I'll do the derivative of the top. So 2 cosine squared, so that's, I'll call this L'Hopital's. So I get 4 cosine theta times the derivative of the inside, which is negative sine theta, minus sine theta. Derivative of negative sine theta is negative cosine theta minus 2, and then I'll do a product rule here. So sine theta times the derivative of that, which is negative sine theta, plus cosine theta times the derivative of sine theta, which is cosine theta, so cosine squared theta. Alright, and remember we're sending theta to pi. So cosine of pi is -1, so top is 4 times -1 times 0 minus 0. So we have 0 on top. Send theta to pi for the bottom. Cosine of pi is -1, so the opposite of -1 is 1, minus 2 times 0 times, well, that's 0 plus, let's see, this is 0 plus cosine of pi is -1 squared is 1. Alright, so I have 1 minus 2 times 1, so it looks like negative 1 on the bottom. And as long as it's a number, then we know we don't have to do L'Hopital's again, so that's good. So we get 0, so that means we have a horizontal tangent at theta equals pi. So back here on the scoreboard, we don't have, it is not a vertical tangent at pi, it's a horizontal tangent at pi. So let's go back to our instructions. Find equations for the horizontal and vertical lines to the curve. Alright, we have all of the angles. Now we have to figure out the equations. Alright. So, I continue right here. So for vertical tangents, a vertical tangent would occur, there's my dinosaur. A vertical tangent would occur like right here, and the equation of that line is just x equals whatever x is. And if it's a horizontal, that'd be y equals some number, whatever y is. So we need to just, for the vertical, figure out what the x is at that angle, and we have our Cartesian equation, x equals whatever. And for the horizontals, if we figure out what the y is at that point, then we have our Cartesian equation. So for vertical, theta equals 0. X of 0 gives you, our x equation is 1 plus cosine of theta times the cosine of theta, or cosine 0 is 1, so I have a 1 plus 1 times 1 gives you 2. So x equals 2 is one vertical line. X of our next vertical is, I'll go 2 pi equals, maybe I'll use the other equation, cosine of theta plus cosine of theta squared. So that's 1 plus 1 squared, so 1 plus 1 is 2, so x equals 2. Makes sense that at 0 and 2 pi we get the same vertical lines. Alright, x of 2 pi over 3. Oh, we're 12 minutes into this problem. We're getting there. So I have the cosine of 2 pi over 3 plus the cosine of 2 pi over 3 squared. So the cosine of 2 pi over 3 is negative 1/2. So I get negative 1/2 plus negative 1/2 squared, which is negative 1/2 plus 1/4 gives you, or me, negative 1/4. So x equals negative 1/4 is another vertical line. I'm going to keep it on the screen here. X of 4 pi over 3 is also negative 1/2 cosine, so you're going to get x equals negative 1/4. So there are my two verticals. Horizontal, my first horizontal is pi over 3, so y of pi over 3 is the sine of pi over 3 plus the sine of pi over 3 times the cosine of pi over 3. Sine of pi over 3 is the square root of 3 over 2 plus the square root of 3 over 2 times 1/2. So I get square root of 3 over 2 plus the square root of 3 over 4. So that's 2 square root of 3 over 4 plus square root of 3 over 4 is 3 square root of 3. So y equals 3 square root of 3 over 4 is one horizontal. And two more. my goodness. Y of 5 pi over 3 is the sine of 5 pi over 3 plus the sine of 5 pi over 3 cosine of 5 pi over 3. So the sine of 5 pi over 3 is negative square root of 3 over 2 plus negative square root of 3 over 2 times the cosine, which is 1/2. Negative square root of 3 over 2 minus square root of 3 over 4. It's the same magnitude of that, it's just negative, so y equals negative 3 square root of 3 over 4. And our last one is at pi, so y of pi gives you the sine of pi, which is 0, plus the sine of pi, which is 0, times whatever the cosine, so we end up getting 0. So y equals 0 is my last horizontal tangent. And I hope I did all that right.